My name is Ronen Botzer, or for the Israelis here, Ronen Botzer. I'm Director of Product at Aerospike. This is a fairly new title, so I'm really excited about it. I'm going to be using it a lot. And you can refer to me as Mr. Director or Dr. Director later when I have more experience, but Mr. Director is fine for now.
Not Mr. Product?
Well, I don't know, that just doesn't seem as dignified. Okay, so let's actually get to this talk. So first thing, what's actually new in the Aerospike landscape / cloud landscape? So since the last summit, we've had a super productive 12 months. I'm not going to say a year because it straddled 2018, 2019. But there's been a lot of releases, and a lot of them actually have consequences on deployments. So even if you're already using Aerospike and have been using it for years, it might be time to just revisit this. You can do it by yourselves. If you feel super competent, you can always do it with a solutions architect from our side. So you can contact support at aerospike.com and just say, like, hey, I need some time with a solutions architect to go over my current deployment to see if there's a better way to do this now. So first thing on our end, here are the main features that were added that are meaningful, and we'll refer to them later on. So first thing, strong consistency. That was a big topic of last summit, but it really makes a difference for deployments. So we'll touch on it later. Rack-aware changes came in 4.0, and a lot of them are config-based, but obviously if you're on the DevOps side, having something that's easier to configure will have an impact. Next thing is, right after the summit was fabric optimization. The kind of replica writes, the node-to-node communication when you need to do, talk to all the replicas are much more efficient now, so there's been a big optimizations there. So if you're on a version older than 4.1, it's something you want to take advantage of. The next thing is quiescence and delaying fill migrations. That came in 4.3.1, and we'll talk about it in a bit. And the last thing is preferring reading from the local rack. Okay, so we'll see in a second that was added to all the clients around November 2018, and that we're going to show how using those together make a difference. And then compression was added towards the end of 2018. There's some people here that use compression really heavily, but it really matters. So the other thing that happened is the SSD manufacturers have been engaged in an arms race. Okay, since in the last 12 months, we've had pretty much all the vendors, all the people that make drives have come out with drives that are faster, cheaper, denser, and more durable. Okay, so whatever drives you're using right now, if you're using bare metal, there's a lot of options now that are around the 100x ACT rating. And I'll get into ACT if you don't know what it is. We'll talk about it in a little bit. And then the next thing is this has trickled down to the cloud vendors. So originally, the problem of Aerospike in the cloud was just the drives were crap. Like, I don't know if I'm supposed to say that. Okay, the drives were not good. You had this huge gap between the bare metal drives that you can get in your own machines and what the cloud provided. The cloud just did not care about speed. It was all about getting the best cost per gigabyte, but these drives are really, really slow. And in SSD land, there's a huge spectrum between performance and capacity and cost per gigabyte versus sort of like ones that are like just optimized for lots of reads and they're not really fast, but it's great for Hadoop. But that's not great for us. So people would have needed more i3 drives, for example, to get a certain workload done than what you can do now. So because all this stuff has happened in the SSD world, there are cloud providers that are buying SSDs. Some of them make their own SSDs, but they've all gotten faster, and that's going to make a difference for your deployments. Okay, so let's go quickly over what quiescing is. So quiescing was added in 4.3.1. It enables smooth master handoffs. So if you've used Aerospike for a while, you know that when you're doing a rolling upgrade, you take down a node. That node used to act like as if it was, it just died. Okay, so there's no way for it to actually broadcast that it's like leaving the cluster or like, I'm okay, I'm just getting out of the cluster, I didn't crash. Right? So the way Aerospike handled it was always like this worst case scenario, which is fine for like a self-healing cluster, but is actually really annoying when you're doing something like a rolling upgrade, which will happen a lot more often than a node actually dying. When you quiesce a node, it removes it from being a master of the partitions that it used to own. So it kind of hands off mastership, but at the same time, it remains in the cluster. So while the clients have still not updated to the new status of the cluster, like they didn't get the new partition map, which is usually a gap of like around 2 seconds, depending on how you set the heartbeats and all that, then it'll still act as a kind of like a waypoint. Like it'll proxy requests the correct nodes. So you don't get timeouts on the client side. Okay, so that's a big thing, and we're going to be using that. In strong consistency, it also counts towards that partition being available, because the decision of whether a partition is available or not has to do with how many nodes are still in the roster, and all these. There's a complex algorithm around it, and there's actually a talk later on at 10:55 that goes into rack-aware with strong consistency mode. So if you want to look at that specifically, Meher, who's here, is going to go into a lot more details about that. So I highly recommend that talk. Once all the clients have discovered that who the new masters are, and once you see that you can track that there's no more proxy events happening, then you can basically now take down the node. So it's kind of like this in-between status that allows for a much smoother transition. The other thing is delaying fill migrations. So again, this was just added in 4.3.1. It allows for faster upgrades. Like we said, originally the algorithm assumes the worst, assumes that the node died. And if a node died, that means that we've lost a certain amount of master partitions, so the replica partitions elsewhere get promoted. And now Aerospike creates empty partitions elsewhere, but for a certain number of partitions, they're only at replication factor 1. Effectively right now. So the whole idea is to quickly fill those so that, to avoid a situation where we get hit by another node going down and now we're going to have data unavailable. Okay, but that's not the case for rolling upgrades. In the case of a rolling upgrade, actually you don't want that to happen because you're taking it explicitly down. You're doing your RPM-UVH, upgrade the thing. It's down for a couple of minutes, that you're bringing it back up. There's going to be a fast restart in theory. And after a few minutes, it's back. So we don't want it to aggressively try to fill these empty partitions because actually nothing bad happened. It's not dead. It's not permanent. It's going to come back. And what we want to happen is we just want delta migrations to happen without any other things going on in the background, because delta migrations now will happen really fast if there are no fill migrations happening. So basically, you can now have a config param that you can set, delaying this thing by a few minutes. If you calculate that it takes you about 5 minutes to upgrade a node, you can delay it to 10 minutes away, right? So worst case scenario, you're asleep and the node died, after 10 minutes, it'll go and make sure that you're back to replication factor 2 or 3, whatever you set. But if you are the operator and you're trying to just go node by node, you want to do it as fast as possible. You don't want to wait forever. You don't want all this noise happening in the background. Delaying the fill migrations is really useful. Okay, so how does this, let's do a review of actually what changed in the cloud providers. So now so far it's what's changed on the Aerospike side. Now let's talk about what's new in the different cloud providers and how these things can be combined for better deployments. So, quick review. Amazon is still the biggest and most popular cloud provider. I'm talking with regards to Aerospike deployments. They've been actually working really hard to close the gap on, say, Google Cloud when it comes to networking. Their networking used to be really, really inferior to Google Cloud, but they've been closing the gap. The other thing is they've been adding a lot of different drives. And these drives are really, really nice compared to what you used to get in the cloud. And again, there is a total arms race going on. There are constantly, the last year especially, there are a lot of improvements that you see in parallel, kind of them trying to get past each other in terms of performance. The old nodes are still powered by Zen, which requires a lot of kind of memory and cores put aside. You can see it in the, say, i3 16XL versus the i3 Metal. You get back a lot of cores and memory. The new hypervisors that come with the new instances is Nitro. And Nitro is really interesting. They offload networking and storage management tasks to ASICs, actually. and then you just get much better performance, and they're much tighter. So the gap between metal and, say, the largest virtual machine is basically negligible. Okay, so that's one thing. But also the cost is exactly the same, so I'm not sure really why you would choose one over the other. But anyway, this is just how it works. There's not really much of a performance gap. I think I'm going to skip this. You guys probably know all of these things. I think the only interesting things to really point out is that first thing, inside EBS is tied to a zone. Okay, so this just quickly, the idea that like you can have EBS and let's say the zone goes down, and now you can attach those drives somewhere else is not true, I believe. Anybody? So I think what you can do is you can take snapshots, put them in S3, and then move that snapshot into creating a new EBS elsewhere. So that's kind of like if you're using this technique to add more durability to Aerospike, EBS still, you gotta know that like it doesn't really help in AZ going down. Yeah?
You can detach and reattach EBS volumes. You just need to keep track of the volume ID.
But in a different AZ?
Not in a different AZ.
Okay.
You would need to snapshot.
Yeah, I'm half asking because it's been a long time since I've done this myself, so things might have changed. You can call me on that if I'm off. The other thing is EBS is encrypted, and the last thing is EBS actually has 3 copies. So if you have replication factor 2 and you have a shadow drive to EBS, you also need to be aware that EBS itself has 3 copies. So you kind of like can decide like how many real copies of the data do I need. So for example, the decision of whether to use replication factor 3 versus 2, if you're using EBS, it's kind of like this would mean 9 copies. Like I think you're okay. Maybe you don't need the really high replication factor. Okay, so, oh good, my timer is not showing me the time. So first thing, let's talk about the new NVMe drives. EC2 instances obviously are grouped into instance type families. In 2018, in the summer of 2018, there was a whole group of 5th generation for the C, R, and M instances, and they're Nitro-based. So these are the ones that really bring in the new hardware. All of them have a 900 gigabyte, 838 gigabyte, so base 10 versus base 2. You can't use 900, it's whatever. That's an annoying marketing number. The full size is 838 gigabytes, and we see from our testing that their performance in ACT terms goes between 30 and 36x. Now, that is quite a wide gap. We're talking about like a 20% difference, and that does affect capacity planning. A lot of times for capacity planning, it just makes sense to think about it as 30x because you don't know what you're going to get under the cover. So, I mean, you might fall on the faster drives, you might fall on the other manufacturer that are slightly slower, but these are still great compared to what you had before. So before, if you think about an i3, the i3 single drive rating for the 1740 gigabytes is 4x. This is 30x, sort of minimum, if you get like the right, sort of the wrong drive. But that's still like fantastically faster. You can make, you can sort of squeeze a lot more from a single node if your workload is the one of high IOPS. And then, just to remind everybody, in Aerospike, because we evenly distribute data across the drives, you get linear scaling out of this. So a full-size machine like an R5D24XL or R5D Metal with 4 drives will give you 4 times that. So it's 120 to 144x combined per node. Okay, so that's kind of like the speed rating of what you can do with this. And that means that if you combine this with compression, you can actually squeeze what was much larger data sets in the past into smaller clusters of these, of these type of machines, because they're going to kind of cover for the having less nodes. You have more capacity in terms of IOPS per node, and you can squeeze more into them. You can kind of like, even though they're small compared to an i3, you can squeeze a lot in. Now, it would be really nice to have something that straddles both the size of i3 and the speed of these guys. If it comes, that'll be fantastic. But right now, you have these 2 classes of, kind of like not huge scale, but really fast drives with modern CPUs and all that are really, really capable. And then you can combine them with compression to actually, potentially really reduce the number of nodes that you have and the cost. I'm going to skim over this really quickly. So the compute ones, the C5s, are really, really nice for ones that have really high I/O. Okay, if you have a lot of TPS, then you need to hit. These ones have the best chipsets, but they're limited to only 2 drives at the largest size. The memory optimized ones are the R5, the R5, R5Ds. The R5Ds are the ones with the drives. That's the difference. And you get double the drives. You go up to 4 on the full size. And the CPU, again, is very similar. So it's pretty decent for these very high I/O workloads. And then the general purpose ones, the M5Ds, they're all actually the same drives. Now, originally when we tested them, they had performance all over the place. But we talked to Amazon, and they admitted they are the same machine. They are the same drives under the cover. And they've made a lot of improvements on their side. Things have kind of stabilized where if you're getting a 900 gig drive, it's the same. And they're like 30x kind of like speed rating. And then there's all these other weird ones like Z1Ds and C5Ns and U1 metals. I haven't found anybody that just fits right into those. They're out there. The Z1D, in theory, is the same type of drive, but you can get much higher CPU. But usually, Aerospike doesn't need that much CPU unless you're doing compression plus a lot of, say, CDT work, which some people in this room do. So that might be interesting for that if you're seeing that your CPU use is really high. Otherwise, it's kind of like, you're not really sure what project to put them in, but they're out there. And then the last thing is there's a whole bunch of instances that nobody cares about. They just have nothing to do with Aerospike. So I don't know. We haven't done much testing with them. I don't know what I do with the FPGA one, for example. So before we said don't deploy, we kind of would recommend to people to not deploy across availability zones. Because the problem was if you were in 2 availability zones, right, you split your cluster into 2, half of your because the data is very evenly distributed, half of your reads and writes will actually go across AZ, and you get a big latency hit on those. Okay, so the reads would suddenly suffer from, an additional 10 milliseconds just because of internode communication. You'd also pay a lot in terms of egress, because some of them monitor you, and actually meter you on calls across AZs, so it was not a cheap solution. People wanted to do it because it's kind of like how you do databases in the cloud. Right? Like if you come from Cassandra or whatever, that's like the standard way to do this. And I can see the advantage of this because you want to be able to protect yourself against an availability zone going down, which does happen once in a while. Not that often, but once in a while. But these were the problems with it, right? Like you got a latency hit and you paid a lot about this. So what people did do for deployments is, to get more durability, you'd use EBS. Okay, as a shadow device, right? So you'd be in one AZ, you'd use EBS as a shadow device. You can move it, or you can deal with it with losing multiple nodes at once. You could create a hot failover where you used XDR to ship all your updates to a half-sized cluster elsewhere. And then the last thing that I think we had some customers have a talk about it in one of the tech talks is actually active XDR deployment. So they were in 2 different zones using XDR, and their application actually sharded so that only half of the writes would go to either side, and they could read from the one that was closest to them. So they kind of simulated what we are actually suggesting now. So what we're suggesting now is because of all these changes, both on the cloud side and on inside the product, you should be at a version that's 4.3.1 or higher. In general, higher versions have more optimizations in them. So the latest is always the greatest, sort of. But you should be at least at 4.3.1 so you can take advantage of these things. So rack-aware is very easy to set up now. You would have the same number, the replication factor be equal to the same number of zones usually. So 2 AZs with a replication factor 2, 3 AZs with a replication factor 3. And this means that every zone has a full copy of the data. And on the client side, you use the read replica policy of prefer rack. Every client might call it slightly different, but basically this exists in all the clients. And because you have all the data locally, you can read from the local rack, and the only thing that goes across AZ is the writes, the replica writes, basically. Originally, so again, this basically gets rid of latency penalty, and the egress cost goes down significantly. We've had people that have saved hundreds of thousands of dollars just on this alone. The problem, though, was originally this was only supported in AP mode. If you were on strong consistency, you couldn't use it until recently. But what's changed recently in 4.521, which is a very recent release, we added a relaxed strong consistency mode, which allows basically to have reads from the local replica. Because originally, strong consistency always read from the master, even if the master was in a different zone. This allows you to read from the local zone, similarly to how you do if you're in high availability, /AP mode. And in the talk later that Meher is going to give at 10:55 is going to go into that in detail. And again, using this combined with quiescence and delay failed migrations, that allows you to do things like rack by rack upgrades. You can now quiesce an entire rack, okay? Wait for all the proxy stuff to end, and take the whole thing down, upgrade all the nodes in the whole zone together, bring it back up, unquiesce them, and then move to the other rack. So for rolling upgrades, that's really, really sped up things compared to how sort of slow and cumbersome it used to be before. And the farther we go back in time, the more cumbersome it is. So we've definitely...
Taking down an entire rack with replication factor too. Yeah, pretty risky point in time while that entire rack is there.
So just be on replication factor 3 and 3 copies. No, I'm kidding. I mean, there's obviously a risk for it, and you don't have to do that, right? Like you really have to measure the risk of losing other nodes in the remaining rack, but that's kind of up to you. Also harass Meher with those questions later because he knows a lot more than me about this. Okay, so an example of a 2AZ deployment, you get really nice high performance because 2 AZs are affected less by inter-zone latency than if you, say, had 3 AZs, which is the next thing. So if you're in 2 AZs, you only need to do replica write to one zone. These are synchronous, right? So like a replica write happens by first thing the client talks to the node that has the master partition for this record, and it coordinates talking to the replicas, okay? Now, Amazon being Amazon gives you no information about cross-AZ latencies. There's not like a place where you can look it up. You don't know what's going on. They don't promise anything in any SLAs. It's good, or moderate, or low, or high. These are very technical terms that they use. So because you don't really know what the inter-zone communication latency is, if you were in 3, you're basically making the risk of taking a really long time to do these replica writes increases, right? So you're more durable, but it increases this time for the writes, and then writes might back up, right? Because this node in the meanwhile can't do anything else. It's waiting to synchronously talk to the other thing. So this record right now is being locked, and you can have transactions start to back up. So there is a cost to being in 3 and 3, but 3 and 3 obviously is more durable. So again, now you can do the whole rack by rack upgrades and not be as worried as Albert here. The other option is to be in 2 AZs with a replication factor 2. So again, every zone has 100% of the copy, but you also use shadow devices. You're using EBS as a shadow device. So now it kind of covers for a loss of a node. Let's say you did take a whole rack down, you lost a node in the remaining rack, you have that you can attach those drives to a new node. So that, again, that's kind of balancing these things out. And then the last thing is obviously combining the two. Each cluster is, in a region is going to be multi-zone, sort of deployed across both with rack awareness. And then you can use XDR across the regions as well. Yes?
As long as AWS keeps charging, though, for inter-AZ traffic, there's really no way to avoid that. It's only about minimizing it instead of
Yes. Yeah. And the other thing is the latency problem. So a lot of people that are very latency sensitive, you don't want to be across AZs without using this approach because half your reads are going to be higher latency. If you're in AZA, you're talking AZB, it's just you're going to be suffering that.
From a replication, optimizing latency on the client communication rather than the replication communication being the key.
Yeah, exactly. And typically, for most people, there's a lot more reads than writes. It might be less of an issue if you're doing 90% writes. You might be like, well, this is not a great deployment for me, but I just want to make sure people know what's out there. Okay, so just in general recommendations is first thing, reevaluate the sizing of your cluster. If you used to be on 20 i3s, revisit this either by yourself or with a solutions architect from Aerospike to see maybe you can move to a bunch of R5D 24XLs that are actually going to end up being cheaper and perform better. The thing I didn't mention about the drives is not only do they have like higher performance, right? They hit 30x instead of say 4x. They're also super low latency. Like if you look at the ACT tests, they remain super, super low latency up until like that point where they fail. You get this, like, it used to be this very hot, kind of like hockey puck, kind of like, or sorry, this kind of slope, gradual slope with older drives, where as you pushed them harder, the latency kind of slowly increased in an exponential way. But drives these days have an almost L shape. They're like super low latency until they just fail. So, I mean, it's really nice. It lowers your latency. If you're latency sensitive, you definitely want to take a look at these. The other thing is, do not use EBS as your main storage. It is not reliable. Now, I checked the website because I had to check the website to just see if they meant durability, because they say they're 5 nines, but they actually say availability. But then if you get 20 minutes where you can't write to the EBS drive, I don't know. I mean, maybe it's 5 nines because it's distributed across all the workloads, but individual customers of Aerospike have had multiple times where EBS just will not take writes for multiple seconds, multiple minutes where they have to call their technical support person to say, hey, this drive is not responding. So actually storing on EBS directly is not recommended. Also, you get very variable latencies, so it's kind of like, I don't know. Yes?
So what do you recommend as opposed to EBS then?
Well, EBS as a shadow device is totally fine. But EBS as the main drive instead of using local ephemeral. So like the R5Ds, all those guys have a local SSD. All the reads and writes will happen to the local. If you use shadow device, that's a secondary write there. And that one is has its own buffer, and it's a lot more stable than trying to read and write directly from EBS. Now, it would be fantastic if it was reliable, then I can see the advantage of it, or if it was faster too. The interesting thing about Azure, which we'll get to later, is Azure actually has 3 classes of network-attached storage. And some of them really have super high I/O and very, very high performance. I mean, you're paying for it, no doubt, but you actually have the option. In EBS, it's kind of like, there's just EBS. The 5th generation instances, by the way, R5Ds, have much better EBS networking. It's a brand new thing. So if you're using also shadow device and you're on I4 or R4, move to R5 just for that, because the networking with EBS is better. And it's cheaper for some weird reason. So they definitely want to push you towards moving from the older generation to the newer generation. Compression may allow you to now fit data sets that were on i3s into these things, okay? And counterintuitively, compression may reduce latencies. If you're writing a large object, most of the time is spent on actually going to disk, okay? The time scale of disk access is very different from the time scale of the CPU. So for the CPU to compress and decompress, let's say, I'm going to use something familiar, a 10K object versus 2.5K and deflating it into 10K and then compressing it back to 2.5K. You're reading and writing 2.5K versus 10K, and the CPU is way faster. So you're actually going to see latencies go down when you're using compression. I mean, should. It depends really on the size of your object. If you have a 500 byte object, it's not going to be the same as if you have like a 10 or 40K object. But definitely for things that are 2K and above, it's worth testing. And the nice thing about it, you can set this on a node-by-node basis to different codecs. You can have Snappy on one, LZ4 on another, Z standard level 1 on a third, and then use another one as a control and compare them after, run it for 30 minutes and see which one, compresses better, what the compression ratio is, what the CPU cost is, what the I/O stats sort of like, how much it costs on the disk, and you can see what the impact of this is. And then you'll fall on the one that fits your type of data, because it's very data specific. Some things compress better than others. Like if all your data was just a string of the letter A, that would compress pretty well. I think. The other thing is move to Amazon Linux 2 as soon as you can. Amazon Linux 2 just comes with better drivers, more up-to-date drivers, and everything, and newer kernels. Is, unless you have something in governance that say you can't move from 1 to 2 until it's been tested by, the security guru, then Amazon Linux 2 is just better, performs better.
So are you saying it's better than Linux 1?
Yes, yes.
How about Ubuntu? Because we found that as older kernel.
I think you're on your own at that point. Do your own testing.
Well, I was just curious if you had any guess.
Just in general, modern, like the latest release of Ubuntu will also have the latest drivers and all that stuff. So if you're on, LTS, whatever it is, Ubuntu 12, it's a little different than, some things are pretty old, especially for the kernel difference. The newer, getting newer kernels makes a big difference here. The other thing is considering using read page cache. If you don't have a lot of read misses, if you're not missing a lot of reads, then it's definitely worth turning this on and seeing how things perform, because we're going to use the OS's page cache for that, so extra memory can be used. Now, if you're missing 90% of your reads because you're kind of prospectively trying to read a record that may or may not be there, then there's an overhead with trying to check for it in the page. But if you do, and you can see this is a stat, but if that stat is really low, that means you probably will benefit from turning this on. Large clusters should prefer uniform balance. This is another thing that was added recently. And if you have a large cluster, you're more than 4 nodes, you get very, very even, much more even data distribution than before, and therefore very even distribution of work, because work is directly proportional to the data, right? So if you're on a 20-node cluster, a 60-node cluster, using uniform balance will give you much better performance and much less capacity planning issues of one node is 15% more than other nodes. So it kind of dictates how many nodes you're going to need. And then the other thing is use multiple partitions on your drives. If right now you're just using the drive as a single device, you will get better performance when you partition them. So here's examples of partitioning them. It basically speeds up things like defrag, because you get a defrag thread per one of these for each device has its own defrag thread. Each device has its own write queue. Each device, so things like recovering from a shadow device. If you had a total loss, you reattached your shadow drives from EBS to the new drive, and now it needs to copy the data locally. That's going to happen much faster when you have more partitions. It's just much more efficient. So we can go up to 128 devices per namespace. So you really can go pretty bananas with this. Now I wouldn't have partitions of 40 gigabytes out there, but keep it reasonable. But definitely having more partitions is more efficient, and you're going to get better performance. i3 drives are more consistent when you over-provision them. When you don't touch, you basically partition them in a way that doesn't touch about 21% of the drive. So you go from 1740 to 1500. You get more consistent performance. For the 5th generation instances like C5D, et cetera, you don't need to do this. You can just use the full drive. And we talked about the cross-AZ and all that. Let's see, how far did they get? I'm moving a lot slower than I expected, so this is going to be a problem. So the gotchas are, make sure to enable ENA. If you are on a new instance that has ENA, make sure to enable it. It might just not be turned on, and there's a link to how to actually do that. Because ENA is a multi-queue network card, and you don't want to use just the one queue and just have cores waiting on being able to use that network card. So you have more channels in it to do transmit and receive. And Amazon could be better. It's now limited to 8 at the most, but you can also have 96 cores in the full-size machines, all using just 8 queues. It's better than just using one, but just be aware of that you want to turn it on for sure. And if you're using CPU pinning, we found out, well, my team found out that right now in Aerospike, at most, you need a ratio of no greater than 4. So if you have more than 32 cores on your instance, you can't use CPU pinning, unfortunately, right now. But there are things that you'll hear later on that are better even than CPU pinning coming down the pipeline, and hopefully they'll have that in like newer Intel chips, they can use these new features. I'm going to skip on, and then I'll skip through this too. Google Cloud is probably, is one of, obviously, you guys know, one of the main competitors. They are really, really trying hard to catch up to Amazon and are doing a lot on their side to improve where they were. They build everything themselves, which is a very Google way to do things. They don't buy gear, they just build their own. So they build their own servers, their own networking gear, their own NVMe drives, which is a weird thing to find out. And they're very opinionated about how to do things right. So weird shit like live migrations that nobody else does is something that solves a problem for you, but also is really disruptive for a stateful system. Not a problem like shutting down app server nodes. They don't have a state. Just roll through and upgrade their latest security patch. It's all great. But in a stateful system, you can't just yank nodes out and then expect what's happening to the data. And it's just very aggressive. Like they'll roll through a zone one after the other. You'll just see nodes going down one after the other. So you definitely want to use things like quiescence and all these other features to sort of buffer yourself against these things that are going to happen. So what do I have to say about this that's interesting? Okay, the local SSDs are encrypted. Okay, so if you were using the encryption feature of Aerospike, that's not necessary in Google on a local SSD. In Amazon, only the EBS can be encrypted. You can turn it on or off, but the local ephemeral is not encrypted. They just assume that kind of like the whole thing gets wiped anytime it rolls. So that's the thing that's protecting you. But in Google, this is how it is. Also, just for terms, sole tenancy is similar to dedicated instance in EC2. It means you own the entire physical machine. And that's something that some of our customers are using to get around a noisy neighbor problems. And then, like I said, live migrations is an interesting beast feature, but we have a way around it now. So the largest deployment of any Aerospike cluster is on Amazon, like by far. We're talking, in the petabyte range. The second largest, hundreds of terabytes, lives in Google. So, sort of the experience is out there. Customers are using cross-zone with rack awareness already and local rack reads. There are customers that are already out there doing that right now. Google is weird. It has machine type families, but they're only for CPU and RAM. In Amazon and in Azure, they come with a specific type of disks and a specific number of disks, right? In Google, there's this interesting concept that drives are like this fungible thing. You just attach a drive. A drive is just a drive. It's like money. There's no difference. You just attach a drive. The problem is that some of their drives are fast and some of their drives are slow. And because of live migrations, you might start on an instance with fast drives, and then they just help you migrate to something that has 1/4 of the speed or 1/6 of the speed, which is interesting for capacity planning because suddenly you need 6 times the hardware. But you didn't know about this. They just do it for you as a friendly gesture. So there are ways around it. And the ways around it are still not exposed. They have a new generation of hardware that they built. 2 minutes? Okay. I guess the clock, whatever. I should use this amazing invention called a clock. So new machines in Google are coming with new drives. They are now very aggressively deploying them to different zones. You will be able to select them in a roundabout way by asking for a specific type of CPU. If you ask for Intel Cascade Lake or better, which doesn't exist, you right now can ask for Skylake or better, and that you get a 50-50 chance of falling on a new drive or an old drive. But Cascade Lake will only be machines that physically have the newer drives. And that is a big difference in capacity planning. We're talking about 6x ACT versus 24x. Or depending on the OS, we've measured it up to 40x. So a little inconsistent there, but you can talk to your own technical account manager at Google and beat them up on this yourself, and we can get you in touch with the right people. Okay, we talked about the gotchas. Live migrations. There's a specific, you get a 30-minute window warning that you can like actually poll for to see that live migrations are coming. And this script specifically kind of like checks to see whether this live migration happens. If live migration is coming, it just puts the nodes into quiesce mode. So then your other zones will take care of things, and you'll be kind of like, you're kind of like bracing yourself before the wave hits. So that's something that I would recommend doing if you're in Google Cloud. Again, talk to your SAs, and they'll tell you about it. And then quickly, Azure, awesome. They're trying to catch up. Second to AWS in terms of data size, they measure it by storage, which is a little ironic. That means 0 in a database world. But they really are trying hard. So the really interesting thing about Azure, since I have half a minute left or something, is that the problem used to be drives that were just not good. You used to get instances with a single drive. So you didn't get this linear growth that Aerospike gives you by having multiple drives, right? If you had a 10x drive, it was still a 10x drive whether you're on a 8-core machine, a 16-core machine, a 32-core machine. You're kind of stuck with what they have. So then we'd recommend people to just use like an LS8. If you are on Azure, the new instances, the LSV2, each one of them only has half the rating of the LS, but you can get up to 10 of them. So first thing, it has a combined of 50x. I would compare these to the i3s. The i3s have 4x, and they go up to 8 drives, so it's 32x combined, and they're each about 1.7 gigabytes. These guys are the same type of drive size, and you can get 10 of them. So you can get more capacity and also get a much higher combined ACT rating. So if you are on Azure, that's a really interesting thing to do. I really hope that they come out with more instances, like also a class of faster drives with smaller capacity, like these 5th generation Amazon one. But basically, because of this arms race, we can kind of expect it's going to happen. The rest is, there are a lot of clouds out there. We have people on Oracle Cloud, actually 2 fairly large customers on Oracle Cloud. So it works. We have people on IBM Cloud, on SoftLayer. Now it's a combination of SoftLayer and Bluemix. These are leased bare metal servers. They work really well. They have really, really nice, like they get the Intel Optane NVMe drives, really good performance in terms of hardware. People have been checking out Alibaba Cloud, which actually have decent drives under the covers, which are 8x ratings, and they're really trying to catch up to Amazon as well. So a ton of competition, and we kind of expect to start showing up in all those other environments as well, if we're not there already. And then, the many other clouds that I don't even have names for. The what? Goat Cloud, yeah, it's my favorite. It's where I run all my Wares servers. A what? What is? I would hope. Any questions? Anyone? Yeah?
Yeah, I have a question. This is more about deployments on GKE versus like VM deployment.
Yeah.
And same goes for AWS.
Yeah.
So do you guys have any recommendation, or you have seen any significant differences?
Well, the significant differences is that everything is wrapped by other things, right? It's like, oh, we get Unix, and we're going to make it better by wrapping it in more Unix-like things. We do have offerings for, all the Kubernetes engines. The nice thing that is about them is that they're all very similar. Now, there have been changes on the Kubernetes side of the world, which is things like Operator came out. And we are planning to leverage Operator to bake in a lot of operational knowledge, like scaling up, scaling down, backups, and all that, so that it'll be kind of like you just hit an API call and it just does it for you. That is something that is on our product roadmap for this year. And we definitely intend to get very, very serious about Kubernetes services, because the advantage for us is it's the same thing, more or less across the board. So doing it well means you're doing it well everywhere. Every single cloud gives it, so the advantage for you as customers is that you can just up and move, right? Like if you're something that's GKE compatible and you can just go to Pivotal Cloud, you can go to whatever, AKS, EKS. I mean, that's the nice thing about it, is now you can treat the cloud like it's supposed to be, which is commodity. And you can take yourself out and move somewhere else. So that's definitely something we're going to be doing, and by the next summit, there's going to be a lot of changes on that side.
So we're going to have to wrap there because we're out of time. But thank you, Ronen, very much.
Thanks for coming.